Hi, everybody. Welcome back. We are doing homework for 521 today. All right, so problem 5-27 says that to ride to school, Elaine takes 7 minutes to ride 18 blocks. It asks us what is her unit rate or her blocks per minute, assuming that she rides at a constant speed, meaning she's not like stopping or slowing down or speeding up. How long should it take her to go 50 blocks? Justify your answer. So the first thing we're going to do is set up a proportion to figure out how many blocks per minute she's able to go. So it tells us that she can go 7 minutes and 18 blocks. So 7 minutes for 18 blocks. Then we're trying to figure out blocks per minute. So for 1 minute, how many blocks can she go? That's our X. That's what we don't know. We're going to go ahead and I'm going to use cross multiply because that's just easier for me. So 7 times X is 7X equals 18 times 1 is 18. Then when we go ahead and write, we need to divide to get X by itself. So dividing by 7 on either side, we get X equals, now this is going to be a decimal. It's kind of a long decimal, so I'm just going to use this little squiggle line, which means about. Oops, did I just bump that? Sorry. About 2.57 blocks per minute for 1 minute. Okay, so now if we want to figure out how many blocks, right, for the second part, how long will it take her to go 50 blocks? Well, I can just create a new proportion. I'm just going to kind of try and give myself some room. I obviously ran out. So we're just going to work over here. Okay, new proportion. So we knew that before she was able to go 7 minutes, took 18 blocks was 7 minutes equals. Now we're trying to say for 50 blocks, right? Our blocks were on the bottom. So for 50 blocks, how many minutes will that take her to go? All right, so that's our proportion. We're still going to use cross multiply here. So 7 times 50, right here, 7 times 50 is 350. And then when I multiply my 18 times X, that's 18X. Okay. Then in order to get X alone, I need to divide by that coefficient out front, which is 18. So dividing by 18 on each side, that leaves me with X equals, and it's going to be a long decimal again, so I'm going to use that squiggle line, about 19.4, and the label here would be minutes. You can squeeze it in on yours. Okay. So there's that. Here's this part from before. Those are our two answers. You need both parts. All right, for number 58, it says that Gail and Leslie are riding in a friendly 60-mile bike race. They started at noon. The graph on the right represents their progress so far. So part A says, what does the intersection of the two lines represent? So when these two lines touch each other right there, see right that spot right here, what does that represent? Well, guess what? That is where Leslie, right, she's behind Gail for a long time there. That's where she is going to catch up, right there to Gail, and eventually she's going to pass her. So that's where Leslie passes or catches up to, right, the actual point there is where she gets caught up to Gail. Eventually she will pass her. All right, for part B, it says, at approximately what time did Leslie pass Gail? Well, we need to know what time is that spot at. It tells me it's about, right, this many miles if I come over. If I come down, it tells me about, I can kind of estimate what time that might be at. To me, when I bring this line down, it looks like it's about 2 o'clock. So I'm going to say 2 o'clock p.m. Yeah. Okay. Then for part C, about how far had Leslie traveled when she passed Gail? So kind of using that same strategy of bringing my line over, I feel like it's not quite to the 20. So my guess is going to be about, right, squiggle line, about 18 miles. If yours is like a little bit 19 miles, right, 17 miles, that's fine. All right. Then part D, what do you think happened to Gail between 1:30 and 3? Well, let's look. 1:30 is like here, right, and 3 o'clock is here. And that looks like when Gail is, her line like flat lines, right? which means that she probably stopped, right? Because she's not gaining any speed. Time is passing and she's not going anywhere. So my guess is maybe she stopped to rest. Maybe she was so exhausted that she needed a break. So I'm just going to say that she stopped to rest. Maybe she needed a little nap. Maybe it was the ice cream truck, that she saw and wanted some ice cream. I don't know. But she stopped. All right. If Leslie continues at a steady pace, when will she complete the race? Okay. So for this, we know that the race was, it told us up here, 60 miles. Okay. So that's this line right up here. I'm just going to try to kind of extend it like that. All right, so that's the end, right? And here's Leslie's line. So I'm going to try to extend her line relatively straight. And then I'm going to see what time about would that be? So if I just it's not exact, right? It's just going to be an estimate, but I'm just kind of bringing it down. Okay, like that. It looks like it's a little bit over halfway between 6 and 7. Right, it looks like it's a little bit over. So I'm just going to say about, I'll use that about symbol again because I'm estimating here. Let's just say 6:40. I don't know. It could be like 6:35, 6:45. I don't know. Something like that. About 6:40. We're just estimating. All right, done with that. Flip it on over. Okay, so next up, we have to write an equation or a rule for each of these tables that we're given below. And then on the set of axes, we have to graph that. So notice we have a nice mixed up board game table. This is not anywhere in order. So the first thing I'm going to start with is by getting this in an order that I can work with. All right, so numbers that are close to each other. Let's see. Ooh, an 8 and a 9. Those are close. So I am going to start with just making a new XY table. And I know I'm going to need the 0 number, so I'm just going to start with 0 and go down to 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, extend it a little bit more. All right, so 8 we saw was 23, so I can fill that in. 9 was 26. Now, when I look at my growth, right, how many am I adding each time? And I am adding, so it's going to be positive. I know I'm adding 3 every time. So if I wanted to work backwards, I certainly could, right? 7 then, if I subtract 3, would be 20. If I subtract 3 again, I would have 17. Subtract 3 again, and I would have 14. Subtract 3 again would be 11. Try to keep these lined up here because otherwise that gets kind of confusing. And then 8, and then minus 3 again would be 5, right? Ooh, now see, even I got off. Okay. 5, and then subtract 3 again would be 2, and then minus 3 again would be negative 1. Okay, so now that I have all of that written, I can write my rule. Y equals, what is my growth? How many was I adding, or most of the case subtracting by every time? That would be 3. So 3x. And then what is my 0 number? Well, I look at my table. Right there is my 0 number, so I can see it's negative 1. So 3x minus 1 would be my rule. Then I can go ahead and graph that, right? So I can see that my y-intercept is negative 1. So on my y-axis, I need to put my first point at negative 1. And then my growth was positive 3. So I'm going to go up 3. 1, 2, 3. And I did label my graph a little bit small. So actually, because I was going up by not 1 every time. Okay, so going up right there. And then I need to go over 1. Sorry, it's kind of small. Okay, then I'm going to go up 3 again and over 1. Oops, I didn't go over. Sorry, this graph paper is so tiny. Okay, and then up 3 again and over 1. And you can kind of see how that line is going to continue to grow. I could also decrease it, right? It's just so small that maybe you can do it on yours. Your eyes are probably better than mine. All right, moving on to the next one. We got enough points on there. We've got 3 or 4 points, so that's fine. All right, so up next, I'm going to try to figure out my next graph, or my next table. So my points, let's see, I have a 0 and a -2. Those are pretty close together. I could do a 0 and a 6. I mean, if we want to stay in positives, that's always an option. So either way, I know I need the 0 number. So 1, 2, 3, 4, 5, 6. Let's just do that, I guess. Okay, so I can fill in what I know. I know that my 0 number is 2. My 6 is 32. So if I figure out what's the growth, right, how many numbers are in between there, right, from here to here, I know are 30 numbers. Now I need to ask myself, how many jumps is that? Well, from 0 to 1, that would be 1 jump. From 0 to 2, that would be 2. Then 3, 4, 5, and 6. So then I could divide this, right, by 6. And when I divide, I know that that's 5. So that means that I can work backwards or forwards, however I want to think of it, and add 5 every time. So 2 plus 5 is 7, right? And then I can just fill in the rest of this. So trying to keep everything like lined up is like throwing me off right now. Okay, it's sort of lined up. The numbers are a little bit off, but you get the idea. Okay, so now I can create my rule. Y equals, what's my growth? Every time I was adding 5, so 5x. My 0 number was already given. That was kind of nice. So it's positive 2. So that right there would be my rule. Right? And then if I go to graph this, since my y-intercept is 2, that means on the y-axis I need to go up to 1, 2. And then for my growth, I need to be growing by 5 and then over 1. And it is positive, so it's going to move to the right. So up 5 over 1. Up 5 again. 1, 2, 3, 4, 5 over 1. I can also decrease this line by growing it the other direction. So 1, 2, 3, 4, 5, and over 1. 1, 2, 3, 4, 5, and over 1. All right, so there's enough points. Now I can connect my graph. Okay, just like that. All right, then for 5-30, it says that we need to translate each point below from symbols into words to form, words, or from words into symbols. So in this case, we're going from symbols into words. So we have -y plus 8, but we're not going to say -y. We're going to say the opposite of y. The opposite of y. You could say plus, or I'm going to say increased by. Fancy words, by 8. Okay. For the next one, I have a 2x, which means that I'm going to be multiplying something minus 48. So we don't just write that. We say 48 less than 2 times x. Okay, just like that. Ooh, now I have a squared in there. All right, so we're going to take the square. That's how we would say that. The square of, now what's that inside the parentheses? The sum, right, because it's being added. The sum of x plus, or and, plus 3. Okay, just like that. All right, for letter E, it says the opposite. So now it's giving it to me in words, and I have to write it in symbols. The opposite of 6 times the square of a number. So if it was the opposite, I know that that's going to be a negative number of 6, right? That's nice and easy. Times the square of a number. So the square of a number, if we have an unknown number, that means x, and squaring it would be that little 2 up there. Okay. All right, flipping it over, we have one more. We have E up at the top here. Oops, you cannot see that. There you go. How's that? A number multiplied by itself, then added to 5. So if a number is multiplied by itself, that's just like x times x, and then added to 5 would be plus 5, just like that. Nice and easy. Alrighty. Number 31, we need to solve each of the following equations for the variable and show all of our steps. We don't have to check. Yay. All right, so we have to solve for x in this case. So that means we're going to end up with a y. Okay, so in order to solve for x, we have like our y equals, right, 2x minus 5. I'm going to try to get the x by itself. So I'm just going to start by subtracting y on both sides. Just got to move them over at some point. So that's going to leave me with a 0 for right now. That's fine. 2x minus 5, now minus y. Okay, then I need to move my x's over, right? So my 2x, I'm going to move him over. So he's positive right now, so I'm going to subtract to have the opposite of that. So now I'm left with negative 2x equals negative 5 minus y. Okay, now my x isn't completely alone yet, so now I need to divide, right, to get rid of the coefficient by negative 2. Keep the negative with it because then it'll save us less steps in the long run, which is always nice. Okay, so what are we left with? Just x on that side. Now, a negative divided by a negative is a positive, so we can just leave that as 5. I'm just going to leave the 5 over 2 part there. And actually, let's just extend this whole line and just divide the whole thing by 2, because otherwise we have big fractions that we don't care about. Okay, plus y, right? Because again, the opposite, negative divided by negative, is a positive. So our answer for x is actually that x equals 5 plus y divided by 2. That whole thing has to be divided by 2. Fun stuff right there. All right, for part B, we are solving for w, right? Of course, we're not solving for p because it's already given to us. So we have to solve for w. So first step that we're going to do, let's see, p equals negative 3w plus 9. I just like to rewrite it, then I don't have to worry about that. Okay, so first things first, let's just subtract by p and put that on the other side first. Okay, so we right now 0 equals negative 3w plus 9 minus p. Look at that nice long equation. All right, I'm solving for w, so I need to move the w's over. So I'm going to add 3w on both sides. We cannot just move the w over right now. We need to keep the 3 with it. So what am I left with? 3w equals 9 minus p. All right, then I need to divide, right? Dividing by 3 on each side. Dividing by 3 over here. Okay, so w equals, I know that I can divide this. Hooray, something I can do. Or I can leave it like p minus 9 like that, divided by 3. Since I can't divide the 9 or the p, like that can just stay right there like that. Okay. Yes. Then, let's see, part C. Okay, I am solving for m in this case. So 2m minus 6 equals 4n plus 4. I'm trying to solve for the m. So I want to move probably the 6 over first. I don't know. Let's just do that first. So I'm going to add 6 on both sides, plus 6. So I have 2m equals 4n plus, I can add that together to make 10. Then I know I'm trying to get m alone, so I need to divide by 2 on either side. M is going to be equal then, when I divide this, right, 2 goes into 4 twice, so 2n plus 2 goes into 10 5 times, so m equals 2n plus 5. Ta-da! Like that. All right, last one, letter D. I am solving for y, so I have 3x minus y equals negative 2y. All right, so trying to get my y's together, I'll just put them on this side, then they'll be positive. So I'm going to add 2y on both sides. That's going to give me 3x plus just 1y, because 2 minus 1 is 1. So that's going to be 0, which is fine for right now. We're not going to leave it that way, but we'll get it there. Then I'm trying to solve for y, so I'm going to subtract by 3x on either side, which means I have just y left on the left. That's funny. Left on the left. Anyways. And then negative 3x on the right side. So there's what y would equal. All right. Hopefully that makes sense. Please continue asking questions. If it is not, thank you very much for watching the video.